Please welcome Adam.
Thanks, Sander. So I have the pleasure to be the last one. I hope that you are also going to be here at the end of the talk. It's already impressive that you have managed to stay till past 4. So own your reliability. Something a little bit about me. I joined Algolia in 2014 when it was a small team of 8 people working in a very specific service. And I was hired as a DevOps engineer, basically to automate the infrastructure and to take care about the deployment, the pipeline. Later on, I also started to take care about security. So today, my responsibility is the infrastructure and the security around it, the automation. And the main thing is I like to sleep a lot. And I like to break things at the same time. And as we have heard today, when things break in the middle of the night, you don't sleep. But sometime I had to find my balance in that. And the thing about Algolia, why all this reliability? So what we do, we provide a search as a service. So we give our customers an API that they contact in order to search on top of their data. And if the search goes down, most of the applications that stop working. If you have an e-commerce store, and the main thing is the search, and the search stops working, or doesn't provide responses, or the responses take too long, the customers go away, and you lose the business. So we have to keep our service up, and we have to keep it performant throughout the range of our customers. And in those 2 years, we have grown pretty big. We have more than 1,300 customers. We do approximately 12 billion search queries every single month, and we power search of one of the well-known and big services like Periscope, Vivo, or the Medium blog. We power their search. They don't do it themselves. Every single time you search there, actually a query comes to our API, and we search on our servers. Throughout the time when I joined the company, we were in 2 regions. We were in France and we were in Canada. Today, we have 15 different regions around the world, and we operate in more than 35 different physical data centers throughout multiple providers, multiple ISPs, multiple countries. This is the map of our data centers, so you see that we cover basically all of it. And the reason for that is that when we search, we cannot fight the network latency, so we have to be close to the customers of our customers. So who owns my availability? That's always the question that you don't ask, and you only start to ask it when you have an issue, like, whose fault was that? Like, who was responsible for this system? Who is credible for this system? And there is actually a cool website for that. whoownsmyavailability.com. Take a look at the website. It will answer all your questions. You will immediately see. It will intelligently scan your infrastructure, and it will tell you who owns your availability, who is responsible for your service to be up. So something about reliability and availability of a service. These are the basic principles that some of us remember from electronics, some of us were trying to forget it. When 2 services depend on each other, they actually decrease the reliability of each other. When they work in parallel, they increase the reliability of each other. And this is something that we have in our system. We have a lot of services that we use. Even if we have a monolithic application, there are still a lot of services that we use. And this thing explodes with microservices. But this is what is the reality of our systems today. When the request is coming into our system, we normally rely on some external service to do something for us. Then we have something which has no documentation, and it doesn't have to be a service that you are running. It might be just, think about the data center, the network inside the data center. You have no documentation of how it looks, because it's not your data center. It's the data center of your provider. Then we have, of course, we have some load balancers of ours, and then we have a database that we rely on. But take a look how far our load balancers, which are redundant, are in the scheme, and what all we rely on. The thing that we are trying to reach is this. But you have to take a look at your own infrastructure if you are there. The numbers for every single one of the components is the reliability of every single one of the components. And that's something that we normally talk about SLA. But what is the SLA? I have found a very nice definition by Palo Alto Networks. I don't really like the Wikipedia definition. It's super weird. And it's a service level agreement, and it's a contract between a service provider and the user, and that defines the level of service that you expect from the service provider. And most of the time when you talk with your provider about SLA or with your customers about SLA, you talk about uptime, about the time that your service is reachable. That's the baseline. In more advanced environments, you're starting to talk about the response time. You guarantee that the response time will be below 100 milliseconds in 95 percentile, or that the error rate will not go over 0.1% of all the requests being sent to your service. But why the SLA? So how much costs a minute of a downtime? Have you ever done the calculation how much it costs for your service? Like a minute of downtime. Here are common SLA levels that we talk about and that you normally can meet in the industry. Starting with 99, that's okay-ish, unless you realize that it means more than 7 hours of downtime per month. And I did some pretty simple calculation. If the company has a revenue of $50 million per year, that means that a single minute costs approximately $95. So if you are depending on a service, or if your whole solution has a 99% SLA, that means it's going to cost you $500,000 per year. And that's only in a case that you are generating money at a constant rate throughout the year. If you have a spike during the day and you are only selling during 8 hours, okay, multiply it by 3. If you are an e-commerce system and you heavily participate in Black Friday, multiply it by 10. And then you see the impact of a single minute of a downtime. But these numbers, they look weird unless you see the downtime per month or per minute or per hour that they actually cause. So most of the services that you are going to meet will have something like 99.9 or 99.95. For example, EC2 instances in AWS have a 99.95. So you can actually see that if your EC2 instances, all of them are down for 25 minutes per month, that's okay. That's what you committed for. Those are the terms and conditions that you have actually accepted. So in this case, it's probably worth reading them and taking a look, what are you committing for? High available services, we are starting to talk from 4 nines up to something like 6 nines. Then we are starting to reach some other limits. So the service that we have built, for example, we guarantee our customers 4 nines. So that's 4 minutes per month. And we internally, when we build the service, we build for 6 nines. So whatever we design with the requirement that it's not going to go down. It has to stay up. Because if our e-commerce customer during Black Friday has a downtime for 1 minute, yeah, like what? We can reimburse what they pay per month? That's probably going to be a fraction of what they actually made throughout the day. But providers like to cheat with SLA. There are a lot of SLA tricks like in definitions, and those are like technical definitions. Those are not like law language. It's really a technical definition. So for example, this took from one of the providers I'm not going to name, 100% uptime. Well, it's cool. It's never go down. But you will get 5% refund after the first 0.05% of downtime, which effectively is 99.95. But they set it at 100%. But 0.05, no one is going to move. 0.04, no one is going to do anything. And even if that happens, you only get 5%. Then there is one other provider providing a storage solution, 99.9 SLA. But the downtime counts if backend responds with errors during 2 consecutive 90-second intervals. So you need to have 3 minutes of error rate, basically 100%, to be counted as a downtime, which is effectively 99.8. And then the minute starts to jump. Technically, with this service, you can have a minute downtime every few minutes, and it will never count, because it doesn't fit the condition. So where is the SLA monitored from? Who monitors the SLA? It should be you. You should have an independent monitoring of SLA. You should take a look how your service looks from the outside. You should also monitor from the inside, but mostly you have a public-facing service. Tools like Pingdom that can give you a very rough idea how your service looks or how your website responds. If you don't know 1000 Eyes, wonderful, amazing service. Give it a try. It will give you a very nice insight on the performance of your DNS, of your TLS connections, of your packet loss, of the jitter in your network. It will give you an overview of your accessibility and performance coming from multiple countries. And you will discover that you might have issues that are not caused by you, but you still need to be aware of that to say who was responsible for it and how could you mitigate it in the end. You can, of course, use the server density. They have a very straightforward way how to monitor services, as Jorge mentioned. Or you can build your custom system. Once you reach a certain scale, all these services, they either stop working, you don't want to configure them, or they become crazy expensive. I have some numbers from our production. So we collect 1.6 thousand metric points, distinct metrics monitoring the performance of our DNS providers. We collect 3.3 thousand different metric points monitoring the performance of our API edge. And we have 73,000 metrics just to monitor the network latency from our monitoring network to our servers. So we know the performance of the whole pipeline, the DNS resolution, the connectivity to the server, and the processing inside the server. And if there is an issue, we can pinpoint it, we can bypass it, or at least we can inform the customer, yes, there is an issue, something is going on. So, hands up, whoever runs a server, or physical, or VM, or something. Okay, keep the hands up. It will be interesting to see in the end who runs the server. Okay, who can restart any server anytime? A single server. Okay, those that cannot, hands down. Who can restart any rack? The whole rack of servers. Okay, and who can restart any data center at any time? The whole data center goes down. Okay, Arno, are you lying or? Yeah. Okay, I cannot restart any data center anytime. Out of those 15 regions, I can restart any data center at any time in 11 of them. But in those 4, we are in the process to be there. But actually, when I was coming here on Tuesday morning, I got a bunch of emails from our monitoring which said like, hey, you lost 80 servers. Like, okay, no one really cares. 20 minutes after, they came back, and it's like, okay, guys, did someone notice? Any customer complained, anything? No, we saw it in the monitoring. The servers are down, so everything was fine. The whole data center went down because of a maintenance. But that's all right. So depends on your application, and of course, your mile might vary, but you should be able to restart the data center because it's going to happen. If you want or not. If you are prepared for restarting a data center, okay, you are fine. But the data center will go down. It happened to any provider, and it's going to happen again. And there are some underestimated dependencies that we do when we are deploying servers. Mainly in case of bare metal, so this really applies a lot to bare metal, and we are running our whole infrastructure on bare metal. And that's a power and network. Sometimes provider says, oh, we put you in 2 different racks. Okay, but if they share the same power line, and the power line has a problem, you just lost 2 racks which are adjacent to each other. Sometimes the network is not really protected. Someone hijacks your IP address, someone makes a rogue DHCP server, and it involves the whole network segment. And you can have a rack which is on the opposite side of the hall, but you are still impacted. So one of the things which is interesting with some of the providers, you can actually choose in which rack you want to put your server. And you can give them a specification, and you can say, can you please give the racks to like different halls? Or can you put them to racks that have nothing in common in your different network segments? And surprisingly, most of them will say yes, of course. But no one ever asks for it. It's a super weird request. And we have tried it on our own. We are deploying clusters in a set of 3 servers. And so we order 3 servers because we need them redundant. There is a consensus in between. And they ended up in the same rack, one on top of each other. For us, that's a 1 server. We cannot live with that. So we're like, guys, can you please spread the servers? Yeah, sure. OK. So right now we have a template. When we send an email, it's like, please spread the servers. Some providers, even here in Germany, allow you to choose a specific data center in which you want to have your servers. And that's super handy. I know about a provider in France who is about to give plans of their data center with all the power lines and the failure domains to their customers and say, choose where you want your server, and we will put it there. Because you have decided that this is what you need. You want them on different power lines, different halls, different data centers, different countries. Choose where exactly you want the server, and we are going to put the server there. A very interesting thing is air conditioning inside a data center. You have independent racks. They are in the same hall. They have independent network segments. But suddenly you get it from your monitoring that one of your CPU cores is overloading because of heat. The temperature is too high, and the server starts to restart. The air conditioning is something that can happen. It happened to us even with the provider who has a liquid cooling, and the server was actually sunk into a liquid, and the liquid started to overheat. You never know. This is a thing that you just cannot fight. So we prefer to put servers as far from each other as possible. And one of the things which is also network. The cables always break. The interfaces always break. And it was an interesting revelation to actually put in the monitoring. When you buy a gigabit interface from your provider, do you monitor that the interface is really 1 gigabit? Because if the cable breaks, the interface is going to work, but it will be 100 megabits. Or it will be 10 megabits. And if you are lucky, it's going to be full duplex, but it might bounce back to half duplex. And you will not discover until the moment when you suddenly have to recover something. You need to transfer a huge amount of data, and you are like, whoops, it's just 100 megabits. I'm paying for gigabits, and you make a support request, and they're like, oh, yes, we fixed it. But you were half a year paying for gigabit, and you didn't get it. That happens. And the network is a big thing. Top of the rack switch, it dies, takes down the whole rack. That's one of the dependencies in the graph. All of your servers depend on a single element inside the rack. And network maintenance, as I have mentioned, the maintenance on Tuesday. Unplanned maintenance, actually it was a planned maintenance. I just forgot to tell anyone. I knew about it, but I forgot to forward the email. So actually my colleagues are going to discover from the recording of this talk that it was a planned maintenance, and I didn't tell them. But sometimes there is a planned maintenance, and they forget to tell you. We have servers in South Africa, and they disappeared out of nothing. So we reached out to our provider, and we are like, OK, where are our servers? And they are like, oh, we don't know. OK, that's nice, but find out. And it took them approximately an hour to discover that their upstream provider was having a planned maintenance, planned for months. Just someone forgot to send them an email telling, guys, there is going to be a maintenance which is going to affect your only single upstream from the country, and you are going to cut everything off. OK, so there is a planned maintenance, but they forgot to tell you. And then there are failing maintenances. That's the best one. You know it's coming, everything is OK, until everything totally blows off. We lost a data center the same way, and suddenly 100 servers disappeared. Like, OK, what's going on? So we called the support, and we are like, hey, we lost 100 servers. Like, is everything OK? Can you send someone there? Maybe it's just the power in the rack. We don't know. Maybe the top of the rack switch died. And they are like, yeah, you know, we have a maintenance, but it's not going as expected. It's like, OK, what do you mean not as expected? Like the servers are down for an hour. It's like, yeah, we are working on that. OK, so failing maintenance. Everybody knows it's failing, but no one can stop it, and you are just like waiting for someone to come and say, finally, okay, enough. That was enough downtime. Let's do something else. But okay, I run on a cloud. I don't have these issues. You know? Said everybody always and no one ever. But the clouds, if something, are not error-proof. AWS goes down. GCP goes down. By the way, on Tuesday, was the last time, started in Asia, looked like a network issue just in Asia. 15 minutes after, oh, it was a global outage of a compute engine. Okay, cloud goes down. All the regions at the same time. Azure has outages. iCloud has outages. Verizon has outages. You can name a cloud provider, there is definitely an outage somewhere in their history that impacted everything. And no one saw it coming. But the important thing is that all of these providers, they have an API. You have never seen the server. You control everything via an API. So why don't you deploy between multiple cloud providers? And if you look at some of the most advanced infrastructures being deployed of services, they are deployed between multiple cloud providers exactly for this issue. Because if you are designing for 6 nines, you cannot be in a single region of a single provider. You cannot be in multiple regions of a single provider. Sometimes you have manual switches. Like when AWS went down some time ago, Netflix had to manually switch their DNS to the other region. Yes. Could have been worse. So there is an interesting network issue that we had, and that's something that you probably will not envision, and it's something that you cannot really control, and that we get data corrupted in transit. And we had our servers with LeaseWeb in San Jose in US, and they were peering with an ISP of AWS in US West, and then our customer had a multiple availability zone setup in US West. And suddenly the customer was like, hey, the latency is like too high. It's breaking our backend. Okay, the latency jumped from 50 to 600 milliseconds. Okay, something happened, that's not okay. So we were trying to ping it, okay? Everything was fine, 50 milliseconds, but once they started to fetch and push data, it jumped to 700 milliseconds. So okay, we started to investigate. So AWS, multiple availability zones, multiple data centers. From our side, it was a single data center. It was only part of our cluster. We have cluster in multiple data centers, but this part we were investigating mainly. That went to the LeaseWeb router that was going somewhere and connecting to AWS. So we have identified the peering point. Okay, that was fine. But we were like, okay, probably the issue is somewhere on the way. Let's reroute the traffic through one of our other data centers and save it. And the latency will be okay. So we have deployed a TCP proxy, which ended at the same router, because the zone was going through the same routers. So all the availability zones were going to the single point. And then it was connecting to our 2 different providers with 2 different upstream connectivities, going to 2 different data centers. And our original plan to proxy the traffic didn't work. We reached out to AWS and we told them, hey, the router in front of your data center is having a 70% packet loss. And the response came, okay, it's not our router. Yeah, okay, that's nice, but it's not our router either. Yeah, okay, they told us to contact their provider to inform them that they have issue on their router. I'm like, okay, it's your provider, contact your provider. We are not in any business relationship with them. Okay, so they admitted that they are going to contact them. 10 hours after came a response which says, oh yeah, the provider confirmed that the router is broken and they are going to fix it. And okay, in our case, we had a multi-data center setup in 2 different autonomous systems. Our customer had a multi-availability zone setup in AWS. Was not enough. Because there was a point that the region was relying on, and everything was cleared throughout this. We had a similar case a couple months ago, the Direct Connect. It's a feature of AWS. You can directly peer with AWS to improve the latency and the capacity of your network. The direct peering in Dublin with one of our providers broke. So the provider invested the money to have a great connectivity to serve the servers with the best latency possible, but this direct peering broke. So we did something similar, like on the West Coast. We have deployed server in Germany, and the traffic from Germany was being proxied via Amsterdam and Frankfurt back to France, just to get around the point which was broken and was dropping. It was not completely down, it was just dropping 90% of the packets, but you cannot work with something like this. And you have a lot of issues that you really cannot influence. One of our ISPs received this default route from one of their peers because one of their engineers forgot to apply a filter. So that basically said, hey, the whole internet is accessible via this provider. 75% packet loss. Like, what do you want to do? And that's in a case that you have a single provider. If you have multiple providers, okay, portion of your servers die, but this one survives. I think it was in last year when Malaysia Telecom, through Global Crossing, propagated routes saying, hey, I'm AWS US East 1 zone. And US East 1 went down. Nothing worked. Slack didn't work. GitHub didn't work. What do you do? That's interesting because at those moments people are like, yeah, like, we would like to fix the code, but the code is in GitHub, which is relying on US East, and we cannot make the commits. And we would like to post the message to Slack to our colleagues, but Slack is down, so we are going to send an email, and we're going to hope that our provider is not storing the emails in US East. And it also happened a very interesting issue with Cloudflare that we use as a CDN in front of our website. And they have introduced a new data center in Qatar. And one day my colleagues came and they were like, okay, the latency to our website is pretty high. Okay, you make a quick trace route, and normally in Paris, where we have our office, you have it like 2 hops to the Cloudflare edge. The latency is like 3 milliseconds. And you saw a hop, and I was in Germany, Middle East, and Qatar. Okay, that's weird. Like, that's their new data center. So I went to the status page, and there was like, oh, we have some intermittent issues from London and like 2 other places. I was like, okay, that's weird. So I picked up a phone and I called them. I was like, guys, I saw it also from Paris. Like, it's not okay. And I have used our monitoring network, and I have done tests from 42 other locations, and all of that ended up in Doha. Like, guys, everything ends up in Doha. So they made an update on the status page saying, like, yes, the whole network is impacted, and we are routing all the worldwide traffic into Doha. In the end, it turned out to be a human fault in configuration, but Cloudflare, as far as I remember, they are proxying approximately 5% of the traffic of the internet, and all of that disappeared. So your site is protected, and suddenly it's not. What do? Oh, you switch your DNS provider, or you switch your CDN. Oh, no, you don't, because your DNS is hosted with Cloudflare, and you cannot do anything. So these are very difficult situations that have to go into your equation of reliability of who do you trust. And as I mentioned, TCP proxy, that like HA proxy, as Matthias mentioned, like for load balancing, it's also a super cool thing for like proxying of whatever somewhere. Because you can have just a single backend, and the server just bounces the traffic somewhere else. You don't need to load balance over everything. You can have a single backend and just flow the traffic through somewhere else. Okay, so networking 101. What mainly happens when you put algolia.com to the browser and you hit enter? You know, like how are you trying to hit the service? The DNS. People always forget about this. It's a super essential service. With no DNS, you got no new connections. And it might not be an issue in your case. If you have a long living connections and DNS goes down for 5 minutes, you don't care. But these things go down. And it happened to a lot of huge providers. It's a packet loss prone. It's based on UDP. The packets can get lost. You will not get a resolution. And the latency of DNS resolutions is normally, depends on your HTTP client, are being counted to the timeout of the request. So if your timeouts are too aggressive, and suddenly your external provider starts to have performance issues and the DNS is low performant, you will hit the timeout and your servers will not be reachable. It's not your fault in the end. The provider has an issue, but your timeouts are too strict. That's why we have 2,000 metrics just monitoring our DNS providers, monitoring their edges from all our locations. And not to mention, DNS providers are very popular DDoS targets. It's because if you shut down your DNS, no one is going to reach the service. Maybe today you can remember the IP address of your load balancer. With IPv6, okay, it's not going to happen. So the interesting thing is that actually having 2 DNS providers in most of the use cases is perfectly doable. There are DNS providers with a great API that you can control the whole DNS via an API, and you don't have to touch it. But somehow people have this subconscious idea that the DNS is the thing that you get for free with your domain, and you come there and you put there your A record, and that's the last time that you see your DNS. That's not the case. The provider doesn't really care about the DNS. It's like a subpar service. If there is someone who runs a DNS for their business, it's a very different quality of service. One of the things to consider in designing a software to mitigate these issues, because you probably are not going to mitigate these issues on the hardware level. Some of them you can with multiple providers, but you can improve it a lot with the proper software design. People rely a lot on TCP checksum providing correct results. But TCP checksum doesn't guarantee that the data is the same that you have sent. The data can arrive corrupted. And the longer the distance, the more probable it is. We were suffering a lot because of this. We have servers in Australia, in Sydney, and we were sending the packets from US East. And by the time they arrived, very often they had a very specific corruption which corrupted the packet inside. It went through Ethernet layer check, it went through TCP checksum, and the packet arrived corrupted into the applications. Yes, we are sending billions of packets, and the probability of hitting this issue is 1 in 16 million to 10 billion, which is not that unreal. When you have a packet-intensive application, you're probably going to hit this. Simple solution, use TLS everywhere. Then you are safe. If you don't use TLS, it's also a different issue, but a TLS will solve this for you. DNS resolving is not working. Very often, developers rely on the thing that DNS resolving is working. It's not. It's a UDP-based service which is designed to be unreliable because you can retry. But does your client retry the DNS request? How many DNS resolvers you have configured on your server? 1? For 8? We have 4, for example. So the chance of not resolving is actually getting pretty small. HTTP calls, that's a big thing. Also very often, HTTP call, also depending on your HTTP client library implementation, might succeed, but actually not return 200. So the service which you are contacting might be telling you, hey, this didn't work, and you are like, okay, the call was okay, the connection is closed, I have sent you the data. That's maybe not optimal. And a lot of HTTP clients have super high timeout. 60 seconds, 30 seconds. I have seen HTTP clients in some languages without a timeout. You have an issue? Okay, it's going to wait forever. And then something on top of it is going to kill it. Do you want to you want your application to wait for a minute or two to get a request that's never going to arrive? Timeouts. It's a very overlooked feature of many clients. And then software operations, just like operating the software in production. Package repositories get broken and are out of sync. Anyone a developer in JavaScript? Using NPM? Super popular thing, you know, like a package disappears, Facebook deployment breaks because they rely on the package. as hundreds of thousands of other developers. There was a broken package in a Debian repository, which was having a dependencies that you could not resolve. It installed the package, and then it blocked your installation of everything because you couldn't resolve the dependencies. Or sometimes the mirror that you are using just is empty. A cron failed. And because it was like delete the data first and then copy the data, it deleted the data, then it failed, and the mirror is empty. And as I mentioned, who can deploy with the GitHub being down? Awesome. That's really cool. Because so many companies, when GitHub is down, yeah, like we use Capistrano, you know, it fetches the repo. GitHub is down, you cannot do anything. It cannot take the local copy. It doesn't accept the tarball or something. So one of my advice is invest in introducing mistakes. Netflix made a lot of buzz around it with their Siamese army and their monkeys, gorillas, and whatnot. But you can do it yourself. It can be a simple bash script, just like generate a random probability to kill the service. Make it run in a cron every minute. It kills the service, and the service doesn't recover. Yeah, maybe you don't want to wake up in the middle of the night to do it by hand. Let it recover on its own. Introduce the mistakes of high latency. There are a lot of tools in a Linux kernel that can introduce a latency, corruption of data, packet loss. You can test your network. You don't have to wait for the issue to come. Or, for example, I have accidentally created a rule which looked like this. And I put them in my IP tables in a wrong order. And yes, once in a while, the DNS response didn't come. And the application which was not handling it failed. And actually, it tried to retry, and it failed again. And it was failing for approximately a second. So the engineer in charge of the application connected to the server, tried to make the resolution, and it worked. And then it worked again. And again. So he disconnected, and the application crashed again. Because with this, once in a while, your DNS resolving will get to the range which is blocked, and it will reject the packet. And no one is going to find out. But it's great, because it's a mistake that you have to count with. In our environment, it produced approximately 0.2% error rate in DNS resolutions, which might be acceptable, maybe not. But definitely, it's something that can happen naturally. The last thing are people. Jorge talked a lot about it, so I will be repeating him. But the interesting thing is who holds the knowledge about the system. Like, there is a common term which is called the bus factor. Like, how many people of your company can get hit by a bus and your company will still continue working? And it's a very important thing because big companies, they call it, I think it was the contingency system. You have like, your president and your vice president cannot fly in the same plane. Or your principal engineer and your CTO cannot be in the same plane. Because if the plane crashes, maybe those are the guys that have the access codes to your key management system, and boom, you don't have them anymore. This mainly applies for when you have on-call policies. Like, do you have on-call someone who actually has the knowledge about the system? Have you trained them? Where is the knowledge stored? Do you have a documentation about it? Can someone even like find how the system works? Or it's a work of one guy who was working on that for half a year and the system works great until it does not. And then you are never going to find out why it broke and how to fix it. And that's the thing what Jorge mentioned is, do people know what to do in case that there is an issue? Because the software knows what to do. And we should really put as much to the software as possible. And it's really, I have to tell you, it's really a great feeling when you just wake up and you get an email which says, you lost the data center for 30 minutes. And like, yes, you finish your coffee and you go to work. Nothing happens. Everything recovered. I know about companies when they have to reboot a server, they have 5 people online at the same time. The person who installed the server, the person who is rebooting the server, the engineers managing the application, because the server reboots once in 3 or 4 years, and they are not sure it's going to reboot. And they need to have the people in place to check that everything is okay. I don't know. If my data center reboots, I expect my monitoring system to tell me if something is wrong or not. I'm not going to go to hundreds of servers and check if every single one of them is okay, because I'm going to do a work of a script or of a monitoring system. And also the important thing is, how do you escalate? What is your escalation policy? Who does it go to? We have implemented a policy that we have a person who is primary on call. Then we have a secondary backup in case that the primary, I don't know, loses a signal. Actually, the 2 people on call, they don't have the same operator. So even if the operator has issues and there is an incident, the other one will get it. And even if this is not enough and they are maybe in an area which like lost power or something, then it goes to the whole team that can have an on-call rotation, like in total, to the whole team, just because the 2 of them were not able to catch the issue. So the on-call policy is a very interesting thing that you can work on. So I will finish with a quote from Sidney Dekker, a very interesting professor from Australia. You know that normally people say everything that can break is going to break. I don't agree with that. I love this quote. Everything that can break will work, and then we will make wrong assumptions about the reliability of the thing. So thank you for your attention. And if you have any questions, I'm happy to answer.
Any questions? No, everyone's tired and wants to go to the drinks. Oh, there's one.
There's nobody else. So what do you do when it's not your fault and when you did everything you said, but eventually 6 nines and you're not delivering it? What do you do then?
Yeah, so when there is an incident, so the question was, what do we do when it's not my fault and it failed, and how do we react on it? We do a post-mortem once the issue is resolved, and we take a look why it failed and if we can do something with it. It was at the beginning when we lost. It was the first time we lost a data center. We were like, can we do something with that? So we introduced a setup when we actually were able to deploy our cluster in multiple data centers. The first time we lost our DNS provider, we introduced a configuration which allows us to have multiple DNS providers. The first time we lost network connectivity, we introduced the TCP proxies, and you iterate, and you iterate, and you iterate, and you iterate, up to basically this state. And it was hard failing, cost us a lot of money. We had to reimburse a lot of customers because of our bad mistakes. But yes, you learn step by step, because some of these things will not apply to your environment. Your environment might be very specific in some regard, and you have to find your way around it. But if you make the path and you take a look how your request goes, what it depends on, what your systems depends on, you will find some points, and then it's just up to you if you say, oh, that's okay, like, it never failed, or it's highly improbable it's going to fail, or you just say, okay, just to be sure, because it's actually, you are paying for a redundant service that you hope you are never going to use. And you are willing to pay a lot of money for it, because when you need it, it's priceless.
Anyone else? All right. Thanks, Adam.